A pictorial representation of surface wrapper operation is shown here. The right side image is after surface wrapper, and you can clearly see the improvement in the surface mesh quality and tessellation. How do we perform surface wrapping operation? What are the steps involved in surface wrapping? Let us see those steps now. First, we need to create a surface wrapper mesh operation. For this, right-click Geometry, and then Operations, and select New, and then Surface Wrapper. Then, select the parts to wrap up in the Create Surface Wrapper Automated Mesh Operation dialog. Click OK. Unexecuted surface wrapper nodes are now displayed under the Geometry, Parts and Geometry, Operations Managers. Then set the surface wrapper properties. If default or custom controls need further adjustment, expand the operations, and then surface wrapper node and update accordingly. Execute the surface wrapper and assign parts to regions. How to set surface wrapper properties? The surface wrapper properties control the input parts and features of the surface wrapper, specifically per part meshing, curvature and proximity refinement, gap closure and mesh alignment. To set the surface wrapper properties, select the operations, then surface wrapper node and set the properties in the properties window. Let us discuss the properties and inputs required for surface wrapper. The first input is of volume of interest. The volume of interest control determines the volume that the surface wrapper extracts from the input parts. To set the volume of interest, follow these steps. Select the surface wrapper, then default controls, and then volume of interest node and set method to one of these properties. Largest internal specifies that the wrapper extracts the largest internal self-contained volume from the input geometry surfaces. External specifies that the surface wrapper extracts the outer surfaces of all parts, that is, the external surfaces. Seed point specifies that a user-defined location determines the surface that the wrapper extracts. Nth largest specifies that the wrapper extracts a particular surface according to volume size. The surfaces are ranked from largest to smallest, and the user-defined volume number determines the output surface. The next two user inputs are about leak detection and gap closure. The leak detection tool accounts for the current wrapper settings and determines if any gaps in the surface would be closed based on the supplied settings. There are two scenarios. No leak. This means specified sizes are sufficient to close any holes or leaks. Leak. If there is, leak reports the leak path through the hole. Then we have to fix it manually. Alternatively, the wrapper settings, in particular the gap closure size, can be modified so that the wrapper can automatically close the hole itself. The gap closure size parameter controls whether gaps in the input surface are closed or not during the surface wrapping process. The surface wrapper leak detection tool is useful for determining whether leaks exist in the resultant wrapped surface that is created from an imported surface. What is a leak? A leak is a gap or a hole that would allow a path to be traced from one volume through to another volume or the outside without crossing through a surface. Therefore, a fully enclosed surface has no leaks. When can we use the leak detection tool? The leak detection tool can only be used if an import surface representation of some kind exists. How to use the leak detection tool? The leak detection tool is accessed by right-clicking on the surface wrapper model node in the simulation tree and selecting Run Leak Detection in the pop-up menu.